Hi there. Today we're going to talk about arithmetic series. So you might remember from the last lesson that we did talk about what a series is. A series is the sum of a sequence. So it's the sum. So adding up a sequence. So for example, if we had the sequence 1, 3, 5, 7, if that's the sequence, we're going to talk about first just finite sequences. So ones that have only a certain number of terms. So in this case, there's 4 terms, and the series would be 1 plus 3 plus 5 plus 7. So if we're actually asked to write down what the series is, this is the way we would write it, just like this with the plus signs. And that is, well, 12 plus 4 is 16. So the series would be this written with the plus signs, and the sum would be that. So that was what you would state. Now, we're going to have to develop a general formula for this so that we don't just simply add up the numbers, especially if we get to have a whole bunch of terms in them. So how do we find the sum of a sequence that's quite large so we don't have to just add them up? Now this was first done by a guy named Carl Gauss, and he found out a certain thing about sequences. So for example, if I have the sequence 1 plus 2 plus 3 plus, let's say we have 50 terms in the sequence. Okay, so there we go, 1 all the way to 50. What he discovered was if he took this and then he wrote it backwards, and so he said this was 50 plus 49 plus 48 plus, and then we all went all the way down to 1. What he discovered was that if he did this and he added them up, what happens? So if I add these two up, I get 1 plus 50 is 51, and then I get 2 plus 49 is also 51, and 3 plus 48 again is 51. And so you'll notice that the pattern goes all the way to the bottom. 50 plus 1 is 51. Okay, so he discovered this if you did this. Now this is 2 of them added together. So what would be the next step? What would he do to actually find the sum of that 1 through 50? So this is where I want you to stop and think about it for a second. So what he did was he said, okay, well, there were 50 terms in the whole thing, and each term added to 51, so he multiplied that. So that gave him 2,550. But that's 2 terms. That's 2 series, right? Because he added the 2 together. So in order to find out what 1 was, we just simply divide it by 2. So that would be 1275. So the sum of this series, 1 through 50, is 1275. Now that's great. You don't have to write all your sequences that way and figure out what it is and then try and figure it out. So we came up with a general formula. So in the next slide, that's what we're going to do. We're going to decide, before we do that, we're going to actually, I want you to stop right now, and using the way that he just did it, I want you for this simple 5-term sequence to figure out what the sum would be. Okay, so stop the video now and you do that. So it's 15 plus 12 plus 9 plus 6 plus 3. That's the backwards way. And then we write it forwards. 3 plus 6 plus 9 plus 12 plus 15. And if we add those together, it's 18 plus 18 plus, and then they're all 18, right? Just like he discovered, they're all 18. So to find the sum, we simply say 18 times, and there's 1, 2, 3, 4, 5 times 5. And 18 times 5 is 90. Again, that's 2 sequences, so we have to divide it by 2, and we get the sum to be 45. That seems pretty straightforward. But now Okay, we're going to create the general formula for the sum of a series. I know for some of you this is the tough part of when we develop formulas, but I want you to be able to see where it came from. So if we have the sum of a series with n terms in it, it is, we start with the first term, then it's the second term, which is the first term plus the common difference, and so on until we get to the very end, which is again the first term plus n minus 1 times the common difference. Again, we'll do the way that Gauss did it, and we'll say, okay, so we'll write it backwards. So in this case, it's st1 plus n minus 1 times the common difference. Now we don't need to keep going and keep writing down the terms because we know if we add this together, it's going to be the same as if we add the second one and if we add the third one and so on. Okay, so if we add these together, so we say plus, so this is 2 times the sum is, okay, so there's 2 of the first term, right, because there's 1 here and 1 there, plus n minus 1 times d. Okay, so now that this is the formula, but we just have to kind of rewrite it. Okay, we need to also think that we have to take this sum that we did, and we have to times it by how many terms there are, right? So that was what we always did in the last one. So we have 2 times the sum is n times 2t1 plus n minus 1 times the common difference. Now let's get rid of this 2 by dividing it, and we do the same thing over here. So that means that the formula is Sn is n minus 2 over 2 times t1 plus n minus 1 times the common difference. Now if you didn't quite catch all of those steps, it's not as important that you get everything out of that. We will do a little bit with developing the formula later, but here is the formula that you are going to use. This is the formula you need to write down. You need to have this formula clear in your head, and I'm going to show you now how to use it. Okay, so that's what we're going to do. We used the formula that we developed in the previous slide. So here's our sequence. Okay, the first term, t1, is minus 4. The common difference, so the difference between these, is plus 2. And the number of terms. Now this one was a bit tricky. You actually have to think about how many terms there are in this. And it's minus 4, minus 2, 0. And I just counted them up. So if you could stop for a second and just count up how many terms you think there are, and then you can check that you're right. I said there were 8 terms. So we go back, and our formula is the sum for n terms is n divided by 2 times 2 times the first term plus n minus 1 times the common difference. Okay? So we're trying to find the sum of the 8 terms that we're given, and that is 8 divided by 2 times the first term, which is minus 4, plus n minus 1 is 8 minus 1 times the common difference, which is 2. Okay, so the sum of the 8 terms is, now you can do this, you stop the video and you do this math, and you should get 24. Okay? Now this is a bit tricky. When this actually asks you to re-engineer the questions. The sum of the first 2 terms in an arithmetic sequence is 14, and the sum of the first 5 terms is 80. Now I want you to stop and actually think about what that means. You're going to have to use the formula for the sum. You're also, okay, so now I want to switch gears and I want to just look at this question briefly, and I want you guys to try this on your own, and I'm going to give you a couple of hints of how to start it, but I want you to actually do the math yourself and come with questions to class. So the sum of the first two terms in an arithmetic sequence is 14. The sum of the first five terms is 80. Now you're going to rely heavily on this formula over here. So you know a bunch of information from this formula. You know that the first two terms, or the sum of the first two terms, is 14. You also know the sum of the first five terms is 80. You're going to need to use this being the n and this being the sum, or this part. You're going to need to substitute this information into this equation. From this you'll create two equations, which you're then going to need to solve together to find T1 and D, which is your goal for this. Your goal is to find the first term of this sequence, okay, and to find the common difference. So I'd like you to try that now and come with it to class tomorrow. Thanks. Have a good evening.